In this video, we're going to talk about graphing rational functions using transformations. So for example, let's graph the function f of x equals 2 divided by x plus 3 using transformations. Now, whenever you're graphing a function using transformations, you always want to think about the basic function that you can use to build up to your more complicated function. And with rational functions, the basic function we're going to be first graphing is 1 over x. So we're first going to graph y equals 1 over x here on the left. And then we're going to apply some transformations and finally end up with the graph of the function we're given, 2 divided by x plus 3. Okay, so if you remember the graph of y equals 1 over x, it goes through the point 1, 1, and also through negative 1, negative 1, and it has these branches. So the first branch looks like this, and the second branch looks like that. Okay, and the important features, or one important feature I should say, of this function 1 over x is that as x goes to 0 from the right, so we're using arrow notation, as x comes to 0 from the right, the function, the output, the y, goes to infinity. Okay, and likewise, as x goes to 0 from the left, that is when you're coming at 0 from the left, the y coordinate goes to negative infinity. And that's why we say this function has what's called the vertical asymptote, x is equal to 0. Now also note that as x goes to infinity, y goes to 0. That as x gets large, the y coordinate gets small, it goes to 0. And the same thing is true as x goes to negative infinity, y goes to 0 as well. Okay, so what we're going to do is we're first going to apply a transformation to this to get one step closer to the function we're interested in. And what we're going to do is we're going to replace x with x plus 3. So the graph in the middle here is going to be y equals 1 over x plus 3. So I simply replaced x with x plus 3. And the effect that has on this graph is to move the entire graph over 3 units to the left. Remember, when it's x plus 3, it's 3 units to the left. And if it was x minus 3, it would have moved the graph 3 units to the right. Now, remember that it moves the whole graph to the left. So if we have a vertical asymptote here at 0, now over here, for this graph, we're going to have a vertical asymptote at negative 3. So negative 1, negative 2, negative 3. Let's draw in that vertical asymptote, like so. And I'm drawing the graph dotted over here, even though the graph is really, the true graph is solid. I'm drawing it dotted so that you know when we finally get over here, the graph we're truly interested in will be solid. So now remember, this point right here was the point 1, 1, and that point was the point negative 1, negative 1. And when you move these points 3 units to the left, well, instead of 1, we're going to have negative 2. So we're going to have the point negative 2, 1. So negative 2, positive 1 right there. So this point moved 3 units to the left. 1, 2, 3. So let's label that. That's the point negative 2, 1 right there. And this point, negative 1, becomes, well, 3 units to the left, it's going to be negative 4, negative 1. So 1, 2, 3, 4. Negative 4, negative 1 would be right there. So let's label that point negative 4, negative 1. And then we'll draw in the graph dotted just like before. So here's the graph. So this is the branch, this is the right branch, and it's basically that branch just moved to the left 3 units. And likewise, if you move this branch to the left 3 units, you're going to pick up this branch right here. Okay, so this graph here, this branch and that branch, that's the transformation, the horizontal shift of this graph to the left. And be aware that the graph is just the 2 branches. Okay, the vertical asymptote is not part of the graph. Maybe I should draw this solid just so that we're aware of that, so that we're not confused. So this is the graph. Do it over here too, like so. Okay, and then the vertical asymptote remains dotted. And likewise, the graph over here, if we did it solid, would look like that, and this one would look like that. Okay, and then the vertical asymptote there is x equals 0. Okay, finally, if we apply one more transformation, what do we have to do to get to our final function? Well, clearly we have to multiply this by 2. So we have y is equal to, finally, 2 divided by x plus 3. And the effect that has on this graph is to be a vertical stretch. So when you take a function, you multiply by a number larger than 1, it stretches that function vertically. So instead of negative 2, 1, the y coordinate is going to be, well, it's going to be, instead of 1, we're going to have 2. right? Because we're multiplying all the y-coordinates by 2. That's what we did here. So negative 2, 2. So negative 2, 2 is going to be way up there. We're still going to have the vertical asymptote of negative 3. That hasn't changed. Let's draw that in, right? Because that was due to the x-coordinate. We're not affecting the x-coordinate with this. We're only changing the y-coordinate. So that point was negative 2, 2. And then this point is going to become negative 4. Over here it's going to be negative 4, negative 2. So right there. Okay, so this graph is just stretched vertically. So it's going to look like this. Something like that. And then over here it's going to look like that. Okay, and it's still going to 0 as x goes to infinity, and going to 0 this way as x goes to negative infinity. Let's see if we can draw these a little bit nicer. So there we go. This is the graph of our final function y equals 2 over x plus 3 that we graphed using transformations, starting with the graph of y equals 1 over x. So remember, when you're graphing rational functions using transformations, you start with the base graph y equals 1 over x, and you apply transformations one at a time to end up with the function that you're interested in. Okay, until next time.